I've been in the blockchain industry for over 5 years now, and it has greatly surprised me just how much and just how quickly the industry has grown. When I first heard about blockchains back in 2011, there were only a few people just talking to each other over the internet and trying to do things, trying to use blockchains mainly for one particular application, which was digital currency. And the community was a very small one, and there was a small group of people that understood that there was a lot of potential, and that understood that this was a new technology, a new idea, in some ways a new way of thinking that could be very powerful and do a lot of things for society and for the world. But the technology was still very new. So over the next few years, the amount of interest in blockchains grew, and people started to realize this isn't just a technology that can be used for digital currencies. It's not even just a technology that can be used in the financial industry. And people started thinking, what else can we use blockchains for? Can we go beyond thinking about blockchains as just being designed for digital currencies, for financial applications? Can we start thinking about them as a kind of infrastructure, as a set of technologies that can be used by almost any kind of application that needs decentralization, and almost any kind of application that needs this idea of a shared memory, that needs this idea of consensus, of having a large group of participants agree on something and be sure about something. And the number of applications that people were interested in started to grow. People were thinking, can we use blockchains for crowdfunding? Can we use blockchains to more efficiently organize crowdfunds, make it more decentralized, make them safer, allow people to more easily trust what they're putting their money into? Can we use blockchains for other kinds of financial agreements, like insurance, like financial contracts? Can we use blockchains for non-financial applications, for other kinds of digital assets, for assets inside of games, for land title registries, for government applications, for healthcare? And the number of applications grew. And people started to realize that the way that we were building blockchains at the start was not sufficient for the task. So at the start, people were thinking that there were only a few applications that people could make with a blockchain, and we should make a blockchain for each one. We can have a blockchain for money, we can have a blockchain for identities, we can have a blockchain for healthcare, and so on and so forth. But then we realized, if we were to do things in this way, then the amount of development effort that each and every team would have to do would just be enormous. Every time you would want to do something new, make a new blockchain application, decentralize something else, come up with some new way of bringing people, companies, organizations in different industries in different parts of the world together, you would need to build an entire new platform from scratch. And it is from this realization that the idea behind my own project, behind Ethereum, came in. What I realized is that instead of having a blockchain for every single application, we can make a blockchain that is more general purpose. We can make a blockchain as a general base layer platform, as something that's not designed to build one particular thing on, but it's not designed as an application, but that's designed as a platform that applications can be built on top of. Blockchains should look more like operating systems. So the idea is, instead of having a blockchain that only understands the rules of one application, we can have a blockchain that understands computer code. And whatever application we want to build, you would write the logic of that application into a piece of computer code, compile it, upload it, and you would be able to run your application, whether it is a currency, whether it is a financial contract, whether it is a system for managing identities, whether it is a system for tracking things in supply chains and stopping fraud. Whatever the logic of the application is, you can upload it onto the blockchain, and the blockchain will be able to run it. So this is the core idea behind Ethereum. So since those early days, the technology has progressed quite a lot. And I think that right now we have a large number of people, organizations, teams that are getting very excited about blockchains and that are getting very interested about what you can do with the technology. People are starting to understand how the principles, how the ideas can be applied in each and every one of these different industries, how they can be applied within a country, between different countries, across the entire world, how they can be applied on small scales, at large scales, by individuals, companies, governments. But the technology is still a major roadblock. The technology is, it's still the case that even with the technology that we have now, it still takes some time to build one of these applications. And there's also a big difference between building an application in 2 days just as a proof of concept, just to show that something can be done, and building something that can actually scale to, serve, and fit the needs of thousands, millions, hundreds of millions of people. And the Bitcoin blockchain right now can process 3 transactions a second. The Ethereum blockchain can process 15 transactions a second. PayPal processes 2,000 transactions a second. The Shanghai Stock Exchange goes up to 80,000. If we need to meet the needs of the real world, we need to scale, we need to improve security, and we need to really think more about all of the different concerns like privacy, efficiency, user experience that regular users have. And these are things that are still in progress. These are things that we have made a lot of progress on over the last 5 years. And we've made a lot of progress on research, we have made a lot of progress on development, we have made a lot of progress on understanding what the different kinds of blockchains are, what public blockchains are, what permissioned blockchains are, what the differences are between the different types, what are the benefits of doing things in different ways, what are the drawbacks. But there is still quite a long way to go. We're still, even technologically, quite far from building something that can serve an entire country, especially one as large as China. And this is something that we still need to keep working on. This is one of the main challenges that still remains in the ongoing development of Ethereum. This is one of the major challenges that still remains in the ongoing development of almost every blockchain project that still exists. So this is one of the challenges. Now, even aside from this, we might ask, we have a lot of ideas, and it seems like this technology is a technology that might change the world. But what else is left in order to get from our vision to reality? What are we still missing? Why are these systems not already integrated into every major bank, every major piece of infrastructure, every system that we use today? And technology is one part of it. I also think that another large part of it is simply time. I think that it takes time for any major technological revolution to fully develop, for people to fully understand what the implications are. And I think it's a very interesting and special property of the internet that we can all be sitting here and that we can hear about these technological developments as they come, possibly 5 or 10 years before they become ready for many of us to use. A third important thing is that we need to understand and keep improving not just the technology of blockchains themselves, but also our understanding of how the specific things that blockchains provide can interact with the needs of existing businesses, existing institutions, existing processes, and existing people. And this is also a challenge. People still need to understand what are the specific benefits that blockchains can provide. We know that decentralization is good. We know that openness is good. We know that transparency is good. But how can those three things translate into specific ways that blockchains can be used to build systems that reduce costs, that have lower fraud, that are more democratic, that are cheaper, that are faster, that are more free and open. How do these ideas translate into specific benefits? And this is a challenge for both the people building the underlying technology and also for people building things on top. So I think one of the very interesting properties of our industry is that it incorporates many different fields of science together. If you are a core developer of any blockchain platform, whether it is Ethereum or something else, chances are you are working every day with computer science, cryptography, economics, game theory, mathematics, computational complexity theory, law, policy, finance, and many other fields at the same time. This is not something that we've seen with many other technologies. And so I think it's very important for many different groups of people to work together to understand each other, for people building things to understand what people want and what people need, and for people waiting to build things to understand what is possible now and what will be possible 5 years from now. And if we can all work together and encourage more collaboration, more understanding, to make the technology better, and to improve our ability to actually use the technology to bring value to the world, then I think within the next 5 to 10 years we will have something very interesting. Thank you.